Okay, this is Chuck Arias. I'm back at you with another video on polynomial simplification. So the problem would give you something like this and say, okay, simplify. Alright, so when you see that, you think, God, what a mess this is. There's so much going on here and everything. So what do they even mean by simplify? Well, all they're really talking about doing is just group all these D4s together. See, here's two different D4s. Let's try to group those together. We'll try to group the D3s together, or D to the power of 3, D to the power of 2. We'll put those together, and we'll put all the constants together. That's it. That's all we do. And what we like to do is arrange these things with the higher orders to the left and the lower orders to the right. So what do I mean by higher orders? The D to the power of 4, that's the highest order that we have, the power of 4. Then we go power of 3, that's the next highest order. Next highest order is D power of 2, or D squared. And you might have power D to the power of 1. You could have D, or D to the power of 0, which is what you have really when you're looking at these constants. All right. So anyway, the idea is we start with the highest orders, and we're going to put those at the left. Okay. So we're going to rewrite this expression. We're going to try to eliminate these parentheses, because that's the first thing that we can start to do to get these things all on equal playing field here. This is an implied plus here in front of this. There's no sign either way, so we know it means plus. All these are plus 6, plus 7, plus 4. All these are going to stay plus, because when we move this bracket, the only thing that's acting on them is a plus sign out here, and it doesn't change anything. However, on these two, the minus sign in front of these brackets means that each term, this minus sign means each of these terms gets their sign changed. So it's going to be minus 9d to the 4th plus 2. Each term, the sign changes. Same thing here. When we change the sign of these, it's going to be minus 5d to the 3rd minus 3d squared, because each term gets the sign changed. So let's start rewriting this thing without the brackets. That's what we're trying to do here first off. So what we'll do is we start off just with an equal sign. This, by the way, up here on the top line is not an equation. It's just an expression. If it was an equation, it would have equals, and it would tell you what it equals. It might say da 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 equals 0, something like this, or equals 3d. It could be whatever. Okay, but in this case, we don't have an equal, so it's just an expression. We just want to simplify the expression. We say equals, meaning we're going to write the same thing. It's an equivalent thing, but we're going to write it a little bit differently. This time, we'll try to just eliminate these parentheses. So first, what we do is we just bring this 6 down. Next, we're going to bring down this. So all we're doing is we're just rewriting the thing, and all we've done is left the parentheses out. Now we know our next is going to be a minus d to the 4th. And a plus 2. Plus because the sign changes because of this minus and this minus. It becomes a plus 2. Now we have minus 5d to the 3. And minus 3d squared. Why minus? Because this minus acts on each term, so this sign gets changed. Alright, so we've rewritten the expression. And what we want to do is we'll start rearranging the terms now. Now we have everything on an equal playing field. We can start rearranging the terms. We want to put the D4s together. We want to put the D3s together. I have one over here and I have one way over here. Now, the next time I write this, I'm going to put those side by side. And I'm going to put the D4s on the left. Then I'll put the D3s. Then I'll put the D squareds. And then I'll put the constants at the end here. So I'm trying to arrange it from higher order to lower order. Okay? So we start off with an equal sign. Next, what's going to be next? It's going to be the first thing I encounter as I scan through here, oh, it's the plus D4, plus D to the fourth. That's the highest order term that I see, and this one is the same order, highest order. It's still the power of 4. So we'll put that, it's already right next to it, but we'll leave it right next to it. And that's it for the power of 4. Now we start over, okay, oh yeah, and let's cross these out as we go. So we've used that one. We've used that one. Let's not get confusing. You know, we start using it again, or we forget to use all the terms up here. So that's why I like to cross them out as I go, if I'm, remembering to. All right, so we scan across here for the next highest order. It's going to be 7. It's going to be D to the third is the next highest order. In this case, plus D, plus 7D to the third. Cross it out. And we'll keep scanning across. Oh, here's another D to the third. It's minus 5D to the third. Cross it out. We've used it. Okay. Now we have constants here. We're not looking for that yet. We're still, okay. Next highest order is D squared. So we'll put this minus 3D squared in and cross it out. Now, we don't have any just D's like, some constant times D. We don't have any of those. That would be a D to the power of 1. But in this case, we don't have it. So we'll move on to our constants. We have plus 6 here. Cross it out, but we want to write it down here. And we have plus 2. Cross it out, write it down here. That's everything. You can see here that everything's crossed out now. We've used everything, and we've got everything arranged and organized so that the orders are together, the 4s are together, the power of 3s are together. There's only one power of 2, but there it is in order. And then we have our constants together. Okay, so let's combine the powers of 4. What do we have? Let's start with the equal sign. Plus 4 minus 9. So if we know how to do our adding and subtracting of positive and negative integers, plus 4 minus 9, that's going to give us minus 5. And minus 5 what? Minus 5 times D to the fourth, because that's what we're talking about. We have a plus 4D to the fourth minus 9D to the fourth. In our heads, we're thinking plus 4 minus 9. That's going to be minus 5D to the fourth. Okay, now let's look at the D3s, D to the power of 3. We have plus 7 and minus 5. So that's really pretty easy. 7 minus 5 is 2D to the third. Now, we could keep crossing stuff out. We know we've used these two. I don't think we need to do it here, but, let's just keep it going just to be consistent. Okay, now, the next thing we come across is D to the power of 2. There's only one, so we don't even have to do any thinking. We just rewrite it, just bring it down. Let's cross it out. We've used it. Okay, and then we have plus 2, plus 6, plus 2. And that, of course, it will be plus 8, and we can cross both of those out. Let's just cross them out all in one. Okay, so we see we've got it all together, and we're done. We have it arranged in order. The highest order, next highest order, next highest order, and the lowest order on the right. And that's it. There's nothing more to simplify. That's as simple as it's going to get. So I hope that was useful, and what we'll do is we'll come back at you with another video and another example of adding and subtracting polynomials. Thanks for watching.